Welcome to Computer Science in 10 Minutes, the Hardware Edition. I'm here. And we gonna turn you into a computer wizard faster than you can say motherboard. So let's get started, okay? So what even is a computer? In essence, it's a machine that follows instructions. But in order to do anything, you need some basic hardware, which is why every computer has 5 non-negotiable parts. That's right, only 5. First up, we have the brain, also known as the CPU's central processing unit. This little chip decides what programs run and when, fetching data from your RAM and telling your other components what to do. Now you can choose between two main brands, Intel or AMD. They compete head-to-head, constantly trying to outperform each other. More cores equals more horsepower. Think of them like tiny brains working together. Clock speed indicates how many cycles per second it runs, sort of like how fast it thinks. Higher is better, but not always necessary. Cache memory helps the CPU access data quickly, but it's limited. Motherboards will also support different generations of CPUs, which is important because newer doesn't always mean better. It depends. Next up, RAM, short for random access memory. Also known as your computer's short-term memory. It holds all your open programs, letting the CPU quickly switch between them. Got too many tabs open? Oh, might need more RAM. More isn't necessarily better though. A lot of times you won't even use half of what you buy. Typically 8 GB is good enough for regular tasks, while 16 GB is better if you multitask, game, or create content. Speed-wise, DDR4 is the current standard, but DDR5 is around the corner. Finally, make sure you get the right kind. Desktop RAM sticks look like this, laptop ones look like this. Next, we have storage, long-term memory. Like RAM, it stores your programs and files, but it's much slower and way larger. There are 2 types, mechanical hard drives HDD and solid-state drives SSD. HDD are cheaper, like $50 for 1 TB, but are really slow. Think about reading an entire book one word at a time. SSD, on the other hand, are faster, like $60 for half a terabyte. It's still spinning, but much faster. Imagine reading that same book word by word, but someone is feeding you the words, still slow, but much better. So putting your OS and apps on an SSD will significantly speed up your computer. Additionally, SSDs are much more durable. They have no moving parts, so no risk of losing data due to a crash. HDDs, on the other hand, well, they spin, so there's a chance of data loss. Plus, if you ever upgrade to a faster drive, you don't have to reinstall Windows, just copy over your stuff. Moving on to the third essential, the motherboard. Also known as the nervous system of your computer, it connects everything together and lets them communicate. Different motherboards have different features, but they all have a few things in common. First, you have the CPU socket where you plug in the brain. Then, we have the RAM slots where you stick in the short-term memory sticks. Next up, expansion slots for things like graphics cards or Wi-Fi. And finally, tons of ports. We'll cover those in our networking episode. But for now, just know that some ports are used for storage devices. SATA for SSDs and M.2 to SSDs. They both connect storage, but SATA requires a separate connector, while M.2 is built into the motherboard. Last but not least, we have the power supply unit, aka the battery charger, delivering power to all your components. It takes 120 or 230 volts and converts it to what your computer needs. Wattage is important here. You need enough juice for everything plugged in. Most pre-builts are fine, but enthusiasts often go for 850 watts or more. Okay, so those are the essentials. Now let's take it up a notch. Servers and workstations pack all this into a single board, saving space and money. These guys are powerhouses, great for running multiple applications or crunching numbers. Laptops condense it all into a portable package, making trade-offs for size and weight. Less expandability, less upgradability. It's a whole other beast. Now that we got the basics down, let's actually build a computer. But don't worry, you don't need this much space. Oh, and I almost forgot, don't forget the case. It holds everything and protects the components. Some cases are super fancy with rainbow lights, tempered glass, and fans for cooling. Seriously, gamers go wild. So here's the cheat sheet. Step 1. Put the CPU and cooler in the socket. Be gentle. It's easy to mess up the pins. Step 2. Insert the RAM into the slot. Watch out for the notch. Step 3. Mount the motherboard onto the case. Align it with the standoffs. Step 4. Connect the power supply. Make sure you plug in the 24-pin connector and the CPU power cable. And Step 5. Install your storage and GPU, SATA or NVMe, which PCIe slot. There are rules to this, but don't worry, we'll cover it in future episodes. Oh, and one last thing, no power. Check the RAM seating first, it's the most common issue. When it comes to peripherals, you've got a lot of options. Printers are probably the most frustrating. Inkjet printers are cheaper, but ink is expensive. Laser printers are more expensive upfront, but cheaper in the long run. There's also USB-C, the new connector that's slowly replacing the old USB, and optical drives. They're basically extinct. But now that we built a computer, how do we get it to do something? Well, once you press the power button, the magic happens. The boot process starts with the BIOS or UEFI. It's a small program that runs before Windows loads. It lets you change settings like the boot order, enabling XMP for turbo boosting your RAM speed, or changing the fan curves, balancing silence with cooling. But don't go changing things unless you know what you're doing. Updating the BIOS is a real headache. And speaking of headaches, that's all I've got for you today. If you want more hardware tips, hit that subscribe button. But wait, there's more. Check out our Intro to Computer Science course on Brilliant.org. It covers everything from programming to AI. It's interactive, visual, and hands-on, making learning fun. I especially like their courses on algorithms and large language models. It explains complex topics in simple terms. Thanks for watching. Keep coding, and I'll catch you in the next one.